In the previous session, we learned how to represent a point in polar coordinates. But there are some other curves and the geometric shapes around, right? We can do the same thing, right? What we did with the rectangular coordinates. Let's say, okay, we wanna graph the circles in polar coordinates. Can we draw them? So circle. If you remember, right, how we were given the polar coordinates using the geometric coordinate system, that was the thing, right? X squared plus y squared, which is equal r squared, as you see, right? So this is basically how we can find the r, and then theta were given arc tangent y over x. So now I want to have, right, if I have r is equal a type of things, do you see, if I took to write the square of the both sides, that would give me r squared, which is equal a squared. And since I know, right, what the r squared is from the right previous equation, which is going to be equal x squared plus y squared. As you see, right, that's why I can tell, right, r is equal a will represent the circle in polar coordinate system, right? So r is equal a will be, right, just a circle, right, with the radius is a, and the center is just gonna be the origin. So this is gonna be my circle in polar coordinates. So this is the first type of the circle, okay, in polar coordinates. There are some other type of circles. So r is equal to a cosine theta. Okay, I can use the conversion formulas we learned, okay, to get, okay, this type of equation to show, okay, if this is really circle. So I'm gonna skip that part, but from now on we need to know, okay, these are gonna be this second circle shape in polar coordinates. When you're given that type of right equation, r is equal to a cosine theta, to draw this shape, okay, you have two ways. The first way is the primitive way. What you can do, you can just give a theta, and then you can find the r, okay, and then you can create your table. Let me give you a couple value for theta. When theta is equal 0, as you see, cosine 0 is equal 1, and then r is going to be equal to a, right? And when theta is equal, let's say, pi over 3, so cosine pi over 3 is going to be equal 1 over 2, and 2a times 1 over 2, which is equal as a, as you see. And I can continue by this value. Pi over 2 will be equal, as you see, cosine pi over 2, which is 0, which is going to be 0. So what I can do, I can combine all these points, right, in the plane to see, okay, what kind of shape I'm going to have. 2a somewhere here, right? This is going to be my, as you see, diameter. So basically my radius is going to be a, right, in this case, as you see. So when you look at this number, that number is going to be my radius of my circle. So as you see, theta is 0, as you see, right? The angle here I'm making with x-axis is 0. That's why, right, r should be equal to a. But when I, right, increase my angle, let's say pi over 3, correct? So I will be somewhere here, but the distance is going to be a. But look at it, when I have pi over 2, which is, right, the pi over 2 is the angle I'm making with the y-axis. So I need to come back, and then I need to come back, and then my radius should be equal 0. So I'm gonna come back in this way, and then my, right, r is gonna be 0. So, but the rest of this, right, will be just, okay, completing this circle in this way, as you see. So from now on, I'm gonna know that if I have the 2a cosine theta, I need to have that type of circle. So, but let's say, okay, I have, okay, this is the case when a is bigger than 0. But when I have a is less than 0, when I have a is less than 0, let me show using a different color, guys, sorry. A is less than 0. This time I'm going to have this type of circle, guys. Okay, this is going to be my circle when a is less than 0, okay? Okay, this is the second type of circle in polar coordinates. And then there's a third type of circle. This time I will use the other trigonometric function. R is equal to b sine theta. Okay, so I can do the same thing, right, for the theta and then r, but I'm hoping, okay, you're gonna guess the pattern, okay, for the circle, okay, if I draw it. So instead of using this table, of course you can use it, but I don't want to go through and then fill it up this table. But look at that. That's how you need to learn, okay, to draw the circle in polar coordinate. That's gonna be, okay, my sine theta radius, okay, when you are given this one. Let me draw better. Okay, this is gonna be my sine theta circle when b is bigger than 0, okay? So, but this is gonna be the circle, okay, when you have b is less than 0, okay? This is the 2b point, the 2b, but my radius is gonna be just b. There are some other shape, of course, but if you want, we can just do some example. Let's say, example, r is equal 2 cosine theta, right? So as you see, a is here, right? 1, that's my radius, and then this is bigger than 0. That is why I need to have such a shape, right? This is gonna be my circle, okay, since I have the 2 cosine theta. If I had the r is equal, for example, 4 sine theta, that would be something like that. So this time this is 2, sorry, this is 4, and my radius is just gonna be 2. And then it should be, right, b is equal here to my radius, and then since the b is bigger than 0, that's why I need to have on the top. There are some other shapes, okay, we can take a look at it. Cardioids, or you can just say, okay, love shapes. Cardioids are gonna be in this form, a plus minus a cosine theta, or r is equal a plus minus a sine theta. So I will follow the similar way what I did for the circle. Instead of, okay, filling the table, I'm gonna give you the general shape of these cardioids. Then that's how we are gonna learn this shapes. When I have, look at that, when I have a plus a cosine theta, so this will make my shapes larger, okay? That's why I'm gonna have the bigger side of this shape is gonna be at this point, and then I'm gonna have the heart here. So this is how I do it, and then I'm just gonna, okay, repeat the process. I'm gonna take the symmetrical part on the other side. This is the case, okay, when I have r is equal a plus a cosine theta, and then this is my 2a point, and this is my a, this is my negative a. Let me, okay, check it out if I did correct. So look at that. When the theta is 0, right, my r value is going to be equal to a, correct? I'll look at it. Yes, I'm here. When the theta is 0, I'm going to be at that point. When the theta is pi over 2, that's the right, the theta here, look at that. I need to write the drawing that way to find out what the theta is. When the theta is pi over 2, of course, cosine power 2 is equal to 0, and then r is going to be equal to a. As you see, right, I'm going to turn it on this much, and then I will go to the right this far so that I can find out what a is. That's why, right, I need to, right, to combine these 2 points. Then look at that, I'm gonna come back, since as you see in the second region, right, I'm gonna have the negative values, and then R will approach to 0, right? And then I will repeat the same process for the other side. That is how I drew it, and you can just go to the same process for the all other shapes. I'm gonna show it to you now. R was equal A plus minus, or we can, yeah, okay, let's keep the A, or you can go with the other letter, A plus A sine theta. Okay, this is the right plus case. As you can guess, right, if I had the R, which is equal A minus A cosine theta, this time I'm gonna have something like that, guys. Sorry. So this is gonna be something like that. This time I will have a heart, right, on the left hand side. So look at that. If you use, right, A is equal theta is equal 0, cosine 0 is 1, A minus A is gonna be, right, the 1 theta is equal 0, R is gonna be equal 0. But when the theta is pi, and then R is gonna be equal to A, as you see, right, the pi, and then that's why I need to go this way, right, by 2A. Okay, I hope you got the idea, okay? Feel free to ask any question if you didn't get that part. Okay, I will do the same thing for my sine part. So let me show it to you, that part as well. Okay. Look at that. This time, since I use the sine t, that's why, right, my cardioid would be, right, on y-axis, okay, instead of the x-axis. So you can keep in mind, if you use the sine theta, okay, sine theta needs to be related by y-axis, x-axis, and the cosine theta needs to be related by x-axis. Okay, that's gonna be my cardioid, okay, when I use sine theta. Okay, this is the A plus A sine theta cardioid. So you can figure out, okay, some values. You can use some values, okay, to figure out if your shape is correct. When I have, right, the negative between those two terms, then the case would be the right opposite of this way. So look at that. That would be my cardioid on the bottom. So R is equal, this time, A plus minus A sine theta. Sorry, this is gonna be the right, just the minus, and the other one, the black one, is gonna be the plus A sine theta. Okay, that's how we draw the cardioids and then circles. And we will learn, okay, how to figure out the area between these curves, guys.